For April 20th, 2020, we are covering chapters 4 through 6 from the Allison text, Multiple Regression, a Primer. Last week, we introduced linear bivariate regression, and we practiced calculating linear bivariate regression with several different examples. This week, we start thinking about multiple regression, and we can kind of think of that as linear regression on steroids. Before we start, earlier in the semester, I posted an additional SPSS tutorial that is not connected to an assignment to illustrate how to enter data into SPSS to create data files and how to recode variables and create indexes and scales. Generally, I would assign this as an assignment, but given that there are only 8 SPSS assignments in the course structure, I ran out of assignments before I could get to this one, but I wanted you to have the information because many of you will need it in order to create data files related to your thesis. So the bonus SPSS tutorial isn't connected to any assignment. It's just to give you instruction in how to create data files and how to recode and transform variables. It's often not enough to look at how a single independent variable connects to or influences a single dependent variable. We talked last week about how that model is really simple and that there are many factors that can influence the outcome of a dependent variable. For example, if we want to talk about income as our dependent variable, there are several factors that influence how much money someone makes. We might think about things like gender, race, education, occupational status, years of employment. All of these things are influential and connected to how much someone earns. Linear bivariate regression can only take one independent variable into account in explaining the dependent variable. Multiple regression or multivariate regression allows us to look at the individual independent impacts of multiple independent variables on our dependent variable. Mathematically, it does this by measuring the individual impact of each independent variable while holding all of the other independent variables constant. Last week, we not only calculated regression, but we also calculated R squared, which told us about the predictive value of our independent variable and gave us a percentage reduction or a percentage explained on how often we could predict the dependent variable correctly by knowing the independent variable, or it was a variance reduction, how much variation is reduced, right? With multiple regression, we do the same thing. We'll calculate what we call partial slopes or b-value coefficients for each independent variable, and we can calculate R squared for each independent, for the overall model to determine how much the variables explain of the dependent variable taken together. Multiple regression gets a lot more complicated, and we're going to use SPSS to do it. I'm not going to ask you or even show you hand calculations for multiple regression. Excuse me. Chapter 4 focuses on how to run multiple regression using SPSS and other statistical packages. And along with today's lecture content, you get 2 new assignments. One will be focused on interpreting regression tables, similar to what we did last week in lecture, and the other will be focused on learning how to run regression in SPSS and interpret its output. Because the 4th chapter includes how to use SPSS to run regression, it will follow and mimic the tutorial file that will be posted this week in connection with your SPSS assignment. Last week, I also provided a number of links on how to interpret regression tables. This week, I have a couple of links on how to run SPSS to do regression and how to interpret its output. Be sure that you take a look at these additional files in the resource area for today's lecture. There are also some online regression calculators, and I put a link to these in the last week. I put the bivariate link in. I think I put the multivariate link in, but the link is here in case you need it. So the first one is for bivariate, where you have one independent variable, And then they have a multiple regression, but I can only see that it does 2 dependent variables. So it would be trivariate. So you have 2 independent and 1 dependent variable. So these are good for doing simple calculations, but they do get cumbersome when you have a lot of cases because you have to hand enter each one of the responses, or if you have more than 2 independent variables. Allison points out a couple of issues that we need to address before we can run regression in whatever statistical package that we're using. So I'm going to spend a little bit of time talking about each of these.